of the things that we don't know yet is it really there? Is the signal there? And we just haven't got the images processed correctly. So that's one thing. The other thing is that it's much farther away from the sun than Comet Lovejoy was. And so there's a lot less material in the sun. The magnetic field is a lot different. So the conditions are different. So in some ways, not seeing it is also telling us something about the specifics of the conditions. This is an area of the sun that's very, very difficult to study. And so having this comet there and having this tracer is putting it into an environment that we're not used to before. And so I think that this is a unique situation. So it may still be there, but also the fact that we're not seeing it is telling us something about the environment. So that's sort of my basic take on it. Perhaps Carl might have some more thoughts about that.
Hi, Alex. Well, it's hard to say. I mean, it's hard to know what the comet is doing right now. We don't know what's left. We don't know if there is a rocky nucleus, a very small rocky nucleus. We don't know if there's absolutely zero nucleus. It could just be a trail of dust and rocks at this point. There may be nothing left at all. And I know for a comet to be able to show up in the SDO field of view, I mean, we need certain in there, certain molecules to be able to glow enough for us to actually see it. So, I mean, one of the questions is what is the material that makes them glow in SDO, and then does Ison have that? And if it no longer has that, why not? What's different about this comet? So we kind of have more questions than answers at the moment, which I know it's really difficult for the people that are watching. They think, well, you guys are scientists. You need to know this. Why don't you know this? You should know this right now. We've got so many questions, and it's going to take a long time to digest all this data. We're getting so much information about the comet. It's really we've been sort of drinking from the fire hose. So I'm still optimistic that we will see something of Ison in the SDO field of view soon, but it does sometimes take image processing. The pictures that go out online, they're kind of part of an automated pipeline of processing, and we have software tools that take a lot longer to run, but they do enhance a lot of the details, enhance the contrast, they reduce sort of noise, we can pick out certain frequencies, we can enhance them so that we can see more detail. It may be that we need to do that before we see Ison in SDO, but I'm still optimistic that we'll catch a glimpse of it.
So I just wanted to kind of reiterate what Carl's saying. I think it's important for folks to know is that scientists don't have all the answers, but that's what's exciting about science. I mean, if we knew all the answers right away, then it would be kind of boring. And so this is a challenge, and this is why we do this, is because we don't really know what's going on. And unfortunately, that means that we don't necessarily get immediate satisfaction of seeing some results, but that's part of the challenge. And also, I've also heard folks sometimes say, well, you guys have to process images, and that's kind of cheating. And, well, not really. I think most people may take pictures from parties or whatnot, and they pull it up in their iPhoto or Photoshop or something, and they have to do a little tweaking because people have got glowy eyes and they're kind of washed out from the flash, something like that. And you're still getting a real image, but I don't think that's really cheating. We have the same sort of thing here. These are really, really faint signals. These are really hard objects to see, especially in a situation where we really haven't done this before. So there is a lot of processing that has to be done, and that's just part of what we have to do. So that, all in all, that makes it exciting, and that's why we stay up late and do all this work, because it's a challenge, and we're always looking forward to finding out something we didn't know and getting more questions really than answers. I think that makes it more interesting. So I just wanted to kind of add my 3 cents there.
There's excitement behind me as people are trying to see if we actually see a comet yet, but I don't think we've got it in SDO yet. But we will show you as soon as we do at this live Google Plus hangout about Comet Ison. We do, however, have an image from SOHO, which Phil Plait is about to show you. Just a reminder, we are taking your questions. You may submit them using the hashtag AskNASA or Ison. And to Phil.
Thanks, Karen. I just grabbed an image from SOHO, NASA and ESA's solar observing satellite, and you can see it here. This was taken at 1748 UTC, Universal Time. Subtract 5 hours, so that's 1248 Eastern Standard Time. And as you can see in the blue, which is the wide field SOHO view, again, you can see the tail sweeping in, and in the red, it continues in. They're not and it's not looking good for Ison, in my opinion. Now, again, this is in my opinion, and I'd like to have Carl and Alex comment on this as well. But if the nucleus, if the solid part of the comet were still intact, I would expect to see a dot. And instead, what we're seeing is a bright smear that fades into the tail to the lower right. But to the upper left, I'd expect it to just kind of stop. And it doesn't. It just kind of fades away and narrows. That's exactly what you would expect if the solid part of the comet were to have broken up. I'm not saying that is what has happened, because comets are very difficult to understand exactly everything that's going on. But I have a strong suspicion that Ison may be an X-comet. Carl, what do you think?
Yeah, I think that's kind of my assessment too. Before I jump into this question, so I'm looking at my own Twitter feed. You can see my little handle at the bottom there, Sungrazer Comments. I've seen a few comments from people that say, when the camera's not on me, I'm looking sad or something. I want to tell people that I'm sad about Ison, but when the camera's not on me, I'm still trying to get data. So my sad face is actually my concentrating face, because I'm trying to look at the SDO images, I'm trying to look at the LASCO images, I'm trying to get information. I promise everybody I'm wickedly excited today. This is a thrilling day for me, regardless of what happens to Ison. So, getting back on point, I tend to agree with Phil's assessment. I was looking at that same image that he's referring to, and I am definitely worried about how the tail, it kind of narrows and it goes to a very fine point at the head. I would really have liked to have seen kind of a blob there and then the tail coming out of it, because that was a big indication there's still an active coma, there's still stuff that's outgassing from the coma, but because it's just a tiny little point, it really comes to like an arrowhead.
How do we know it's the comet's first trip? And in answering this, maybe someone could, I'm going to throw it to starters to Carl, and anyone else can jump in afterwards. Answer where this comet came from. What is this Oort cloud? Whence it originated?
Okay, so the Oort cloud is basically the reservoir for a lot of the long period or non-periodic comets that we see in the solar system. So if we kind of wind back the clock a bit to when the solar system was forming, we had all this material that was starting to kind of clump together and everything. A certain amount of the material got flung right outside of the solar system. And if you imagine our solar system, we've got the sun at the center, then the planets kind of revolving around that, almost like a record, for example, and the planets kind of follow grooves on the record. Now, surrounding that record way outside of it is a sphere, a complete sphere of big chunks of ice. So they're the Oort cloud comets, and they're really right at the edge of basically so far away from us that the sun's gravity can barely cling hold of them. It's just about got hold of them so they don't drift off into interstellar space. But they're it extends to about halfway between us and the next nearest star. So it's really a huge distance out. Now, what happens is as our galaxy rotates, so our galaxy is like a big pinwheel. We're just one little dot of junk in this big pinwheel that's spinning around. Everything's moving around, and the stars kind of move, the solar systems move relative to each other. And occasionally we'll get a star that's relatively close to our solar system, and the gravity from that star will just be enough to kind of give a nudge to some of the comets in the Oort cloud. And that's what will happen to Comet Ison, I guess, a few million years ago or so. There had just been some sort of gravitational nudge that was just enough that it started to feel a slightly stronger influence from our sun's gravity, and then sort of started to slowly fall into the solar system. And so basically that's what the Oort cloud is. It's this reservoir where all this stuff comes from.
All right, another question that has been asked by a lot of people, and I'm going to throw this one to Phil Plate, is if it survives its trip around the sun, when and where will people be able to see it from the ground with the naked eye?
Okay, that's a good question. It may be a moot point at this point, since I'm starting to be very suspicious about the longevity of this comet right now. Longevity of this comet right now. But if it stays rising the east, the comet should be to the north of that, so to the left, upper left, and over time it will be moving more and more north. In about a month or so, in early January, it'll actually be crossing the north pole of the sky. It's going to get very close to Polaris, so it'll be up all night. But for the next few days and couple of weeks, it would be up before sunrise. Now, what's peculiar about this is that it's also visible after sunset. And you might not think that's possible, but just the way the geometry works out, right after sunset, if you face west and look to the north, which would then be to the right, the comet will be there. But for those of us in the northern latitudes, it'll be closer to the horizon after sunset and tougher to see. So my suggestion would be to get up early and look for it before sunrise. And that is, again, given that it stays intact. With this latest SOHO image of the head all stretched out the way it is, I'm not very hopeful at this point.
I just want to let everybody know who's watching out there that we have more than 27,000 viewers right now. So a lot of comments are getting backed up. We're trying to go through questions. We've got until 30 time on this hangout, and we're going to get through some more. Keep sending them. Use hashtag AskNASA or Ison, or put them up in your comments on YouTube. But before we go to another question, I want to throw it back to Alex Young, who is a solar scientist, and one of the things people are interested in from the solar aspect is how the comets can study the atmosphere of the sun. He wants to talk a little bit about what we're seeing with SDO on the sun per se.
So let me share my screen real quick here. Okay, so what I wanted to talk about is what exactly is the environment that the comet is seeing, and what exactly it means. So let let me talk to you. What I'm looking at right now is, hold on, it's flickering. Okay. What I'm looking at right now is an image from the Solar Dynamics Observatory, 171 angstrom. So that's the wavelength of light. This is extreme ultraviolet light. This is like neon signs maybe. And those magnetic fields are where solar activity comes from, where we have huge explosions called solar flares and coronal mass ejections. And so we really want to study that magnetic field and understand it so it'll tell us why the sun is doing what it's doing. And the problem is we can study the magnetic field close to the visible layer, the visible surface of the sun, but as you move farther out into this wispy corona, it's really difficult. And normal instruments have a really hard time of studying this. So this comet, as it's traveling through, it's leaving its material, and its material is also magnetic, and it follows these magnetic fields. And this gives us an opportunity to see and study these magnetic fields in a way that we normally couldn't do with our instruments. So nature is giving us this unique opportunity to study these magnetic fields. So I just wanted to point that out because this is just really unique opportunity to study something that normally we couldn't do. And not only do we get to enjoy comet physics, but we get to enjoy solar physics all at the same time. So it's a two for the price of one. And so that's kind of my take on it.
All right. That was some of the live SDO imagery that Alex was showing us. There are comments coming in that people want to see the comet already, and of course we do too. We are hoping that somebody can spot it in this imagery, and the SDO team here in the Solar Dynamics Observatory Mission Control Center is working on seeing if we can spot it. However, we have been watching Comet Ison with a number of observatories over the last year, and one of them we got a question from somebody about the Fortis sounding rocket, and I'm going to toss to Carl Badams if he knows anything about what the Fortis sounding rocket, which launched about a week ago, I believe it was November 19th, if they got any interesting data.
Actually, it's funny you mention that because I have absolutely no idea. I'm sorry.
All right, then. Good to know. The only thing I know for what it's worth is that they were excited about their data. I don't know what they saw either. Great. Well, then, let me take another question, which I'm going to throw to Phil, though, if anyone else has opinions.
Fortunately, it doesn't look like that's going to help much. And there have been comets in the past. Comet McNaught back in 2008 was in fact enough to see during the day. I went out at noon, blocked the sun by putting it behind my house, and then I could see the comet as a glowing point in the sky. It doesn't look like Ison's going to be able to do this because, like I said before, like we've been talking about, kind of looks like Ison's broken up. I'm still waiting for new data from SOHO. I don't see anything yet, but I'll update that as soon as I find it.
All right. Just a reminder that you are here for NASA's Goddard Plus Google Hangout on Comet Ison. We just lost Alex, and he's off to data. And Dean Pesnell, the project scientist for SDO, back in a moment to tell us what we're seeing, why we're not seeing anything, what to think about that. And in the meantime, I'm going to go back to another question. Which I will throw to Carl, which is coming from Christoph. And the question is, will Comet Ison accelerate or decelerate after perihelion?
Excellent question. So the sun is a massive gravitational force in the solar system. So as Comet Ison has come into the sun, it has been going faster and faster. It has been accelerating at a really remarkable rate. And I believe, right around now, its peak velocity was about 360 kilometers per second, which it's about 0.2% of the speed of from the sun. It is going to slow down because as it moves away, it's going to feel that the sun's gravity is kind of pulling it back, but it's going too fast. It's not going to get kind of pulled back and sucked back in. It's going way too fast for that. It's still going to fly off out, and it's going to go right out of the solar system, but it will gradually decelerate.
Thank you for that, Carl. I want to re-identify all the people we have today. I am Karen Fox, here from NASA's Goddard Space Flight Center in Greenbelt, Maryland. We have in this room where I am sitting, which is the Solar Dynamics Observatory Mission Control Center at Goddard, we have Alex Young, who is a solar physicist here. We also have Dean Pasnell, who's the project scientist for that observatory, SDO. Carl Adams is talking with us from Kitt Peak Observatory, and he is with the Naval Research Labs. And we also have Phil Plate, who is the Bad Astronomer. He is a blogger on slate.com. And I'm going to hand over now to Dean Pasnell. He is that project scientist for SDO, and he's going to look at some of what SDO is seeing live right now and tell us what he sees in those images.
And do I get to see some images?
Can you share my screen?
Hold on a sec. We are just getting those images up. But Dean, if you want to start and just tell us a little bit about where SDO is pointing and why.
Okay, so right now SDO is pointing a little bit to the left of the sun because that's where Comet Ison Ison, which is what other people like to see, this water ice. Even the The cool thing about the SDO images is we don't see the comet as it goes by. We see the debris it leaves behind for a long time. And for Lovejoy, we saw stuff sitting in the corona for 45 minutes or so. And so the thought is that it's not watching the comet, it's watching the debris as it tries to adjust from being this very cold material to being at several million degrees in the solar corona.
But if I can jump in real quick, with Lovejoy, we know that we had